Okay, circles, chapter 6, lesson 3, the equation of a circle. Now, what you will have learnt at GCSE is the equation of a circle with centre origin 0, 0 and radius r is x squared plus y squared equals r squared, where r is the radius of the circle. Now we can extend that to deal with a circle that doesn't have a centre origin, as centre randomly say AB. So centre AB, radius r. And the equation for that is x take away a squared, the x going to the centre, plus y take away b squared equals r squared. It's just a slight extension of what we had there. That's a really important formula that you're going to need to memorise. So we stick that on a flashcard and learn it. Okay, on to example 4. So example 4 gives us a centre of a circle is 5, 7. It tells us the radius is 4 and asks us for the equation of the circle. This is very, very straightforward because all we need to do is substitute in the centre of the circle, AB, 5, 7, substitute in the radius, 4, and then we've got our equation of the circle. So it's going to be x take away 5 squared plus y take away 7 squared equals 4 squared, which is of course 16. And that's it, that's all we need to do. So example 5. This says we've got a circle with equation x take away 3 squared plus y plus 4 squared equals 20. And part A asks us for the centre and radius of the circle. We can pick the centre off straight away because remember it's minus a, so a is 3, minus b, so b is minus 4, because 2 minuses makes a positive. Radius, the common area would be put at 20, but it's actually going to be the square root of 20 because it's r squared. So r squared is 20, so r is root 20, which we can simplify down to root 4, root 5, to root 5. You can leave it as root 20 though. We're then asked to show that the circle passes through 5 minus 8. So all we need to do here, to show it passes through 5 minus 8 rather, is show that those coordinates work with this equation. So if we put x equals 5 in and y equals minus 8 in, we should get the answer of 20. And if the answer is 20, it proves that coordinate lies on the circle. If it isn't 20, it proves that it doesn't lie on the circle. So let's put in those coordinates. So if we do 5 take away 3 squared plus minus 8 plus 4 squared. So that's going to be 2 squared plus minus 4 squared, which is 4 plus 16, which is 20. So a tick that indicates that we know that it proves that it lies on the circle. I mean, you can write a sentence, it's therefore 5 minus 8 lies on the circle. Okay, on to example 6. This says that the line segments AB of a diameter of the circle, where A is 4, 7 and B is minus 8, 3. Find the equation of the circle. Okay, so it's just a quick diagram. So B minus 8, 3, A 4, 7, and we want to work out the equation of the circle. So to work out the equation of the circle, I'm going to need AB, which is the centre of the circle, and I'm going to need the radius. Now to work out the radius, I can either work out the diameter and then halve it, or I can first work out the centre of the circle, then doing a bit of Pythag, I can work out the radius of the circle. I'm going to work out the centre of the circle first. So the centre of the circle is going to be the average of the x coordinates, which is minus 8 plus 4 over 2, average of the y coordinates, 3 plus 7 over 2. So the centre of the circle is minus 2, 5. Now, To work out the radius, centre of the circle is -2, 5, point A is 4, 7. So we can see we need to go from -2 to 4, which is 6 across, 5 to 7, which is 2 up. So applying a bit of Pythagoras theorem, we're after the hypotenuse, so we square, square, add square root. So 2 squared plus 6 squared, square rooted. So r equals root 36, root 40. Meaning r squared is 40. So that bit of working was superfluous. Now going back to the equation of a circle, x take away a squared plus y take away b squared equals r squared. And it does help if you write that down each time, because it will help you remember it in the long run. We have x take away the x coordinate, which is -2. So minus 2 is +2. Y minus 5 squared equals 40, because r squared is 40. Right then, on to the last example, example 7, this part of the chapter. We're told that we have an equation of a circle as x squared plus y squared minus 14x plus 16y minus 12 is 0. So it's given it in a slightly different form. And what we need to do is work out the centre and radius of the circle. So we need to put it in this form. And then we can pick off the centre and the radius, or the radius squared. So first thing we're going to do is rearrange it. So I'm going to gather up all the x parts and gather up all the y parts, and then stick the number to the right hand side. So that gives me x squared, take away 14x for the x parts, y squared plus 16y for the y parts equals 12. Next thing I'm going to do is complete the square on each of these brackets. So x take away 7 squared minus 49 plus y plus 8 squared minus 64 equals 12. So all we need to do is halve the x coordinate and subtract whether that number is squared, halve the y coordinate and subtract whether that number squared is to complete the square. But that's basic GCSE. Now shifting both of these numbers over gives me x take away 7 squared plus y plus 8 squared equals, what's that going to be? 76 plus 49 is 125. So from that I can pick off that the centre is 7 minus 8. R squared is 125, meaning r is the square root of 125, which is 5 root 5. So centre 7 minus 8, radius 5 root 5. Okay, that's all the examples for the third part of this chapter. So if you now have a go at exercise 6C on page 119, and it carries on to 120.